Everyone. I think I'm taping this and move things around. Here's my problem. This Thursday, um, which we could have a meeting, I'm just realizing I'm here in Evergreen. Rick was with me, and I was talking to a social worker about a graduation that is tomorrow, Thursday, at 6 o'clock. So I'm not going to be able to attend the meeting tomorrow again. And so I decided to take some time now and tape, at least show what we are doing here with Sarah. So basically, we are doing uh, some work on the heating line, and there are two routines that are used for that purposes. One is this routine here, which is now gone. Uh, Heating 1875. So let me compile that one. It's compiled right here. And the other one is this decomposition function that is kind of prepared to do the helium decomposition. So basically, what I did in this first routine, it calculates the entire flux of broad and narrow component altogether, and then it saves um, the normalized helium data, the valley, um, in that particular region, and and that information is read in the second routine is decomposition, where it does some a couple of Gaussian decomposition. So let me show the output and the result. Um, and I'm doing now for record 10. So records 10. It is the helium 1 function. What it does, it's pretty much normalize the heating line and calculate the entire flux emission. And this, once that is done, it save it, and that saved information is read in this routine decomp for the same record. And 2 means that I'm trying to fit two Gaussians, one for the broad and one for the narrow. And GF is the fit, and WS is the wavelength. GN equal 1, I don't remember what that was. Oh, it is a keyword that allows me to see the final plot. So let's see how that works. So the first thing I do is just to normalize. Now, see this wing here that belongs to sodium line? So what I'm doing, just to help with the decomposition later, I'm feeding the continuum through that. So physically this is not correct, because the continuum should be kind of a flat here on top where the cursor goes. And let me show you where the continuum should be, the real one. Should be something like this, right? And this downfall here is the sodium wing. And this kind of a core reversal going in emission is the sodium emission core. So this is a good continuum, but the fact that this wing goes down, when we do, at least in my ideal routine, when we try to do um, the Gaussian fit to the broad component, this wing here push the continuum down, and it's giving some spurious result. So then I decided to uh, make a fake continuum, but it gives a good, at least better result in helium. For instance, for now, I can see the continuum is decent up to here, and it's decent there too. Probably I could be a little bit better, make it a little bit higher here, and then down. Yeah, try again. And these routines are done in such a way that gives you the ability of trying different attempts. Okay, so I'm happy with that. And then I save it by clicking in this right-hand side of the window. And now still in the first routine, helium 1, I'm going to calculate the emission flux from here to there. And then I'm happy with the result. Everything is saved. So it was saved, and what you're seeing here is a plot that comes out of the second routine. So the first routine saved an emission flux of 3.89, and the valence already included in the profile. So now we want to do the composition. So let's tell the code to find two Gaussians between those 2 points. And that's what it does. So the result shows that the center of the first Gaussian, which the broad component, is at 34 kilometers per second. The center of the narrow component is at 6.5 kilometers per second. And the difference between the measurements of the entire flux emission, including broad and narrow, and the entire model, which is two Gaussians, the difference is 6%. So I'm trying to keep this difference in less than 10%. But as I was mentioning to Sarah yesterday, we are having some consistent results that I don't know well how to explain. First of all, this 6 kilometers per second here of the narrow component is saying, hey, the narrow component is 6 kilometers per second in the bluish part of the spectrum, or the red part of the spectrum. So the interpretation that you could get is, okay, all of that is coming from a blob of gas that is falling down, radially towards the star. So you could come up with that interpretation. But it shouldn't be a Gaussian because a gas doesn't fall globally with the same velocity. So it kind of, I don't know how that is physically possible. That's the first thing. The second thing, when you look at the blue model, the model in blue, and the real data in red, so the model, as you can see here, it overshoots here, but it goes under here, overshoots here, goes under there. So what I'm trying to say is maybe two Gaussians is not a good approach, physically speaking. And so if I repeat, probably not for the 10, let's take another record, number 11. So when you look at the profile, so you have I could see a broad component here, and I could see another one there, and a narrow over there. I could see those two. So then we would have a broader component here, another broader component, or a blue and a red wing, plus the central emission. Try to do the continuum again. Yeah, do again. So this looks good here. Probably not there, but I don't care for this part. So I will accept this. Calculate the entire flux. And accept. And then go to the fitting. So the continuum model is at 1, so that's good. Again, I'm having the center of the Gaussian at 6 kilometers per second. And again, there is this mismatch that is very consistent. So the broader component alone is not able to explain the features we observe, So I don't know. Now the fit of the two Gaussians is pretty good, right? The whole enchilada and the model. So I email Sylvia asking her because I don't know so well how to play with the parameters in this routine. I have to dig myself in, and I'm having a hard time to understand the coding. But as far as I remember, I think she had the ability of fixing some points and then have the software determine what would should not be floating parts of this profile. So that's where we are. And if you guys can have a meeting tomorrow, that would be good. I will not be able to have a meeting tonight, so I'm all dressed up because there is a conference that I have to go. Um, so Saturday I have this graduation here, and I hope you guys can make it. It would be great if you guys could come. I would like if Sarah could say something about what she does. That would be good. Although I didn't put her name in the program because I didn't get any confirmation. I know Shaunak is traveling, so anyways, just that's it.